Now it's time to get a bit more technical. It's time for the technical stuff. Because at the core of all of these discussions lies just one fundamental question, and that is, how do we actually build next generation data centers? And that is where our technology suppliers come in. They are the companies that create the power, the cooling, and the infrastructure solutions that keep data centers running smoothly, efficiently, at scale, and sustainably. So in the next 24 minutes, I will be speaking with 3 key industry leaders about the innovations that are shaping the next generation data centers. So please join me in welcoming to the stage Carlo Brouwer, Managing Director at Stultz. Please give it up. Thank you. Please find your table. Thank you so much. Next up, Mark Garner, Senior Vice President at Schneider Electric. The second table is for you. And finally, we have Sanjay Kumar Sainani, who's Senior Vice President and CTO at Huawei Digital Power. Yes, give it up, please. Yes, dear audience, when you put 2 nerds together at a table, you run the risk that they will never stop talking. Now, I know myself, I'm quite a nerd, and I love everything technology related, so to protect myself, and you for that matter, I brought a timer. So every conversation will take 8 minutes. I know that's going to be a challenge, but I'm sure we will succeed. Right, Carlo? Coming over to you here. Is your mic working?
Yes,
Test.
it's on.
It is working, it is doing so. Now I'm gonna set up my timer. There we go. We have 8 minutes exactly.
Right.
The clock is almost ticking. And there we go.
Good.
So, let's do some proper introductions first. Carlo, you're the Managing Director at Stultz.
Correct.
And Stultz is, and I quote, a company specialized in high-end solutions for climate control, and of course also the cooling of data centers.
Exactly.
Exactly, and we talked already a little bit about liquid cooling. Now, traditionally we use air cooling, right?
Right.
Think of those big
All
fans, air conditioning.
Big fans, big tornadoes going through the data center.
And now we're talking about liquid cooling,
Exactly.
because that is potentially the new solution.
It is. Well, it's driven by the high densities now of power, where air has reached the limits. So the rack power is going up, and by air, 50 kW is the max. They're really struggling. So we have to go to liquid cooling. Liquid cooling, but all the data centers, like the edge, enterprises, hyperscalers, co-locators, they're all faced with those challenges by themselves or by the customers.
So how is it going in terms of adoption of liquid cooling?
Well,
Where are we today?
Yeah, we had to adapt from air to liquid, but for that you need other equipment. You need to bring the liquid to the server racks. You have to bring the liquid into the data rooms. For that, we developed the CyberCool CMU, called the CDU, to bring the liquid to the server racks.
Now, we don't have just one type of liquid cooling. We have several types of liquid cooling. Direct to chip, I think.
The direct chip, liquid direct chip, and we have the immersion. And those 2 technologies is the technology that we see the most in the data centers now, whereby the immersion cooling takes up about 20% and the rest 80% by direct chip cooling. Those may shift, those may vary. Immersion cooling is very good when the densities even get higher again, where even direct chip cooling gets to the limits.
So for the people in the room that are not considering themselves as big nerds, can you explain to them direct-to-chip liquid cooling, how does that work exactly?
Yeah, we bring the liquid direct to the chip, into the server. In a way, it's an old technology. It comes from the gaming industry to place where we just cool the chip itself and get the heat out directly and not indirectly what we do with air. So therefore, the power can be higher and we get the heat out easier. And that's what we do. And by immersion, they actually submerge into a liquid to get the heat out directly from there.
What kind of liquids are we talking about then?
It's a non-conductive liquid, otherwise we would have some accidents if we do that.
That would
If it
be a whole different challenge. Yeah, yeah.
Yes, that would be a challenge.
You don't want that, no.
So
Okay.
yeah, that's what happened. Those are the two technologies.
Now, with sustainability becoming a priority, we see regulations are pushing for greener cooling solutions. How is that impacting the adoption of liquid
Yes,
cooling?
it's a bit contradicting because on one hand, liquid cooling allows higher temperatures, so it's easier to reuse the heat. The heat is already in the liquid, so we don't have to transform it to liquids. That's good, but the servers actually would like lower temperatures, so there is a conflict. And that's something we have to work out, how we can work that out and find a compromise somewhere. It will be a compromise.
Are you positive about the future when it comes to regulation and sustainability goals?
Absolutely, absolutely. Because if you look at Amsterdam, for example, and the other cities, they're really pushing for reuse the heat. And liquid cooling makes it easier to reuse the heat. So that's a positive side.
So if you could name one challenge that potentially keeps you up at night,
Yeah.
what would it be?
I think the challenges are that if you look at Greenfield, it's a new design of designing cooling systems for data centers, but also the infrastructures on the data centers are different. Brownfield, we have to look at how can we adapt brownfield, the liquid cooling into brownfield. So that's going to be probably a hybrid solution. So we have a combination of liquid and air, and those are the challenges. I'm not awake from that at night, but there are challenges.
So, well, how do you see the future then? Would it be a hybrid model? Is that the most feasible one?
I think the majority will be hybrid because there's a lot of brownfield and greenfield also, but that's easier. The brownfield is the biggest challenge, and they're both there. So yeah.
So, in just one sentence, or take two sentences if you
I'll
like,
try.
because we are doing a great job here when it comes to time management.
Doing my best here.
Great. So, in a couple of sentences, well, how would you see the future of data centers? What is the ideal picture here?
Well, I don't think there's an ideal picture because the future is liquid cooling is there and it's there to stay.
Yeah.
Because the high densities are there to stay.
Yeah.
I think by the time we solve everything, something new comes up. And that's the challenging in this market. By the time you think you're there, there's a new challenge.
Yeah, it's always evolving.
It's always evolving, it's always moving.
Is it a fun field to work in?
Absolutely.
It is.
Absolutely.
Would you agree? Oh.
Well,
yeah? Yeah? Okay. Okay. I think they are. Oh, we're doing an absolutely great job. So, thank you so much.
You're welcome.
Can I have a big round of applause
Thank you.
for Carlo
Thank you.
Brouwer from Stoels? Thank you. Going to our next speaker. Setting up my timer again.
Hello.
Hello. Hello. Let's see. Here we are. We will have 8 minutes for you too.
Okay.
Is everyone okay? Yeah? Great. So here we go. We have 8 minutes.
Okay.
Clock is ticking. So, Mark Garner, you're the Senior Vice President at Schneider Electric.
Yes.
And for some proper introductions of Schneider Electric, I quote, "It is a global leader in digital automation and energy management, helping data centers navigate the growing power demands with smart and sustainable solutions."
Correct.
Correct?
Yeah.
All right. So let's shift to one of the biggest constraints in data center expansion today, which is, of course, the looming power crunch.
Yes.
Isn't it? So many see it as an obstacle, but I saw that you describe it as a call for innovation.
Correct.
Do enlighten us. How is that a call for innovation?
So I think the panel touched on this as well this morning around innovation in so many ways. It's not just around the technology we're putting in data centers, how we design, build, and operate data centers. It's where we build them, how we build them, and then how we interact with the ecosystem around the data center as well. So I touched on maybe a few points there in terms of the how we build them. my colleague there was just talking around liquid cooling. That's changing, so it's starting to drive a different infrastructure that's required to deploy data centers that are agile and have the ability to cover many different customer types. So we have to innovate in that design and how it works and how it can switch between customer and the people who are deploying data in those data centers. In terms of the innovation of where we deploy them, we know that there's constraints around power in so many different geographies across Europe. However, there isn't a constraint against power across the whole of Europe. There are geographies in where I'm from in the UK, northeast of England, which we've talked about before with QTS. In Scotland, there's huge opportunity there around starting to look at different areas to deploy data center. And then the last piece is really around how we work with that ecosystem. And I bring utilities into that. Better transparency, more visibility around where we're going to build, what we want to do, and then working with the utility companies to really look at green, clean, renewable energy sources that we can go and deploy.
You're quite positive about the future, aren't you?
I am.
Yeah.
I am. I think there's a lot to be positive about. We are in a data-driven world today. So we have to build these data centers. We have to find a way to address these challenges that we have.
Yeah, absolutely. Data-driven and AI-driven. AI is often mentioned as a game changer for energy management. So how do you think can AI contribute to making data centers more sustainable?
So this is a really key point for me. AI is going to drive the data center growth, but it's also the thing that's going to drive efficiency within data center. So I've been in the industry now for just over 7 years, so fairly new in comparison to most people here. But when I first came into the industry, we were talking about liquid cooling. We've been talking about it for nearly 7 years now, and probably longer than that. But over the last year, over the last 18 months, it's really started to become reality. That deployment and the deployment at scale. The deployment of scale of liquid cooling is going to drive efficiency in terms of the operation of data center, a reduction of PUE, power usage effectiveness. And that's a really key output, really key deployment and change in how data centers get built. Continue to challenge the infrastructure that goes into a data center. One of the things that we really focus on in Schneider Electric is how do we build infrastructure and products and systems that are circular in design and being able to reuse and modernize and extend life.
Sustainability is super important.
Absolutely. And AI is helping us with that design of equipment and extension of life of equipment as well. And then finally, there's the AI in the management and monitoring of the systems within the data center, using that technology to drive more efficiency and drive more sustainability on the back end of it.
Amazing. Now, we often hear about alternative energy sources, right? And partnership with utilities. But what are the most promising strategies to ensure reliable power supply for data centers?
So we've got to look at the where we source power from at the moment, and I think this goes back to almost the first question around the looming power crunch that we have. There is this opportunity to be able to source renewable, local energy supply. We have to look at different systems around gas turbines and other opportunities. We see this in the US already. They're starting to deploy on-site demand generation of power rather than pulling from the grid. And I think there'll be more of that that we start to see in Europe as time goes on.
That would be very interesting, yeah, and very needed, I think. So if there would be an action that we could take to bend the energy curve, to drive towards that sustainable growth, what would it be?
So maybe if I just touch on the bend the energy curve.
Yeah,
this is something that Schneider's introduced. I've still got a few minutes, haven't I?
No, we're fine.
Minutes,
we're fine. Good. Doing a great job again. Yeah.
So bend the energy curve is something that Schneider's started to talk about and introduce into the industry over the last couple of months. Between 2010 and 2020, the energy consumption in a data center has really decoupled from the demand for data. So data went from 2 zettabytes in 2010 to 64 zettabytes in 2020. Energy has stayed pretty flat.
Yeah.
So we've built efficiency into the data centers. We've reduced PUE and everything else through the optimization of data center operation. From 2020 to 2024, that curve has changed. So we are now on a similar curve in terms of the demand for data, which continues to grow and has doubled over the last 4 years.
Yeah.
Now the energy curve is on that same spike. And we need to find a way to decouple that energy curve from the data demand to really drive sustainability and sustainable deployment of data centers. There's 2 areas where we think there's opportunity to be able to do this. One is around PUE. So the current forecast around PUE is that we'll get to around about 1.
For the people who don't know PUE.
Power usage effectiveness. So it's a measurement of how effective you use the power within the data center.
Exactly.
We think that, it's dropped from 2010 to now to around about 2.2 to 1.5. We think by 2026 to 2030, it'll go to about 1.4. For us to get down to about 1.2, we really bend that energy curve. And this is where liquid cooling and the change in the infrastructure around the data center, looking at how we use chillers in a different way to cool at a higher temperature, the same as what the servers are working at, really starts to drive efficiency and reduces the impact and demand on the fans within the cooling infrastructure. So there's one opportunity there. We think we can reduce the PUE further than what's already been forecasted with the new technologies on the market. The other one is around the compute, the innovation that's coming from the big server manufacturers out there and the new technologies coming out. That will drive down adoption of that, and faster adoption of it will drive down energy use even further because they're so efficient in terms of how they operate. So we think that by that time will be 17% reduction in terms of energy if we do that.
That is amazing, isn't it? Thank you so much for sharing your insights. And I think,
3 seconds
which is amazing, right? Thank you so much. Going to our final guest of this panel. Yes, thank you. Here we go. We too have 8 minutes. So, hello, Sanjay. Hello. You are the Senior Vice President and CTO at Huawei Digital Power. And to give proper introduction, that is a global leader in digital power solutions, helping data centers scale efficiently while meeting sustainability goals. Is that correct?
Absolutely.
That is correct. So Sanjay, AI is evolving at an unprecedented pace, driving explosive growth in data center demand. But not all data centers have the same requirements. How do you see this AI-driven disruption reshaping the industry?
Well, I don't know how many Star Wars fans are here, but if Master Yoda was here, he would probably say that much to learn you still have, but great progress you have made.
Wow.
We live in an amazing era. We've been in the industry for 35 plus years, and this has never been more exciting than where we are today. Last quarter of 24, OpenAI O1 preview, first of its kind reasoning model, amazing performance.
Absolutely.
AI rendered Alan Turing portrait, what sold for $1 million plus. AlphaFold 3 kind of predicts how proteins will attach to DNA. I mean, this is new frontiers, clearly. And then 2 weeks back, you have DeepSeek.
Yep.
Need an applause here now?
No.
No, clearly surprised almost everyone and thrilled many. What that tells you is that there are many pathways to AGI.
Yes.
That is eventually, we are on the cusp of that. Having said that, there's also a lot of work happening in the semicon industry, right? I mean, Blackwell architecture, 92 billion transistors, 30 kilotrillion operations, new procedures for 1 nanometer process nodes coming up. And that's where what Mark was mentioning about the future is about more performance with less energy, because every time you go nanometer down, you are able to get more performance and much lesser energy. There are other challenges out there too. So clearly, a lot happening in that space. It's very obvious that for all of this to work, you need compute, data, algorithms, and then we had the previous panel here, not to mention energy and capital. So this is an amazing place in terms of where we are right now and the kind of stuff that's going on. But data centers are not the same, right?
No.
In the morning, we heard that if you're going to look at data centers or companies that are developing the LLMs, that's where the data center is staying in country, which is why you're seeing gigawatt data centers in the US and in China. They won't go out until a lot of sovereignty, regulation, security, intellectual property is managed. However, once this model transformer is developed, you need to train it with domain data. Domain data doesn't sit only in China and the US, it sits everywhere. By the way, you are not just consumers, you're also the product here. And so those data centers will eventually come here because you got to train those models with local domain data. Once that model is ready, you now need to inference it, and that's what we've been talking about, the edge everywhere. So there will be at least three different buckets of data centers in terms of how we go out there. And hey, the future is bright out there.
The future is right out there, and we already heard a Yoda quote. I love that. I love that. So, with AI, chips, workloads evolving rapidly, you touched on that already a little bit, scalability is becoming a critical challenge, right? So what strategies can data centers adopt to keep up with the demand while ensuring sustainability?
In many ways, it's a perfect storm out there, right? I mean, grids, the demand is so high, grids are in most cases strained, in some countries exhausted, right? And so when you start thinking of that, you need to figure out, some of the key strategies. BYOP has been there for 24 months now, bring your own power. And I think now there is a new, not new, but something close to that is go to power source. Go closer to where the power is available, because you really need massive investments to bring power out there. There's a lot of consideration there in terms of energy mix, right? I mean, you have renewables, you have coal, wind, battery energy systems. But utilities, aggregators will have to, find ways in terms of regulation, financing, incentives to kind of make a very strong mix of energies to bring the right value to the consumer. So that's one strategy. The minute you say BYOP, it's very interesting, because the minute you say BYOP, you basically are looking at you have power and you need better demand response. That's where you start offering battery energy storage systems as a strategy. Or you would have, where you have no energy. And that is where you would look at, supporting it in terms of with renewable gas on site, or, fuel cells on site and so on. So that's on the BYOP side. The minute you want BYOP, siting strategy becomes very important. That means where would you put it? That's zoning. I'm with Huawei, so I spend a lot of time in China too, and I can tell you there are dozens of multi-gigawatt campuses in China. And these are zoned. Zoning basically means adjacent industries also come close to that zone. Because the minute you have gigawatt of power required, investment flows. The minute you have investment, there's one byproduct or two byproducts of a data center. Of course, you generate data, you generate heat. Now you can sell heat. So you basically are trying to create a circular economy. So the second strategy is getting the zoning and BYOP done.
Yeah.
But there's a third very interesting thing that happens in our business of data centers, which is when you are building these data centers, you also are able to put together the necessary frameworks in terms of the flexibility, because there is so much unknown out there. Until recently, or until 2-3 years ago, data centers were designed inside out. You need a 2 megawatt data center, you need a certain technology, you go to the utility, you buy 4 megawatt of power, whatever is the PUE. But now, when you have hundreds of megawatts of data center, energy is the key issue. So you need to decouple the energy source and the data center itself. Mark mentioned about decoupling in terms of carbon footprint and all, but this is, the word is similar, but I'm trying to make a different point here. I would rather create a data center with a 200 megawatt, 500 megawatt energy center and not worry too much about what data center will come in here. Because one thing is sure, you need a lot of energy. And if you have an ecosystem, you also know you're going to generate a lot of heat. And so an energy center approach where you don't go from inside the data center to out, but you look at energy to the data center is a very interesting strategy that I would prescribe in the given context.
So we have less than 1 minute left, but I really want to end with this question. So in hopefully one sentence, Huawei is deeply involved in shaping the future of digital infrastructure, right? So how is Huawei addressing these challenges?
Flexibility, speed is super important. So reference architectures and modularity becomes the playbook for almost every vendor, player who wants to adapt to this. I believe, and I'm sure many of us would agree, that it's not only going to be data, compute, energy capital that's going to be important. I think Mark alluded to it, but I think innovation will be a key to success in this game.
Innovation will be a key to success in this game. Thank you so much, Sanjay.
Thank you.
Yes, and while you're applauding, please can I have a big round of applause for all my dear panelists over here. Thank you.